Need help? Call our cybersecurity team and book a consultation with us today.
So first of all, I want to thank everyone for showing up tonight and attending. It is appreciated. I know everyone is busy these days, and whether people are showing up for our Wednesday during the day sessions or our Thursday evening sessions, I do appreciate it because it's time out of your schedule. Hopefully you get value out of this. Hopefully you're enjoying and learning new things. We are a Cisco user group, but today we're actually going to cover AWS networking. And a lot of the items that we're going to cover for AWS will apply to other clouds such as Azure and GCP. I have quite a bit of AWS experience when it comes to networking. I have a little bit of Azure experience when it comes to networking. And GCP, I'm a little more theoretical. So, but I think all of the vendors will have some things in common. I'll try and point those out along the way. If you have a question, please just go ahead and interrupt me. So we'll start with a few basics just to get us started, and then we'll move pretty quickly into some secondary concepts, and then we will end with some designs. Kind of peppered throughout will be some either best practices or recommendations. And like I said, if you have a question, you can just pop it in chat, or if you came off mute, you can just ask it. That's totally fine with me. Okay, so just a couple of quick housekeeping items. Even though we're covering the networking and adding in best practices and adding in design, please don't assume that you could just build and launch based on these slides. You really can't. I could probably spend 40 to 80 hours going over all the different components in AWS just for networking alone. It's a huge topic. So we're not going to do it justice, but I think we're going to set a really good, strong foundation. And that's important, right? All the demos I'm going to do today are done in what we call a free tier account in AWS. And everyone who RSVPs, whether they attend or not, will get a copy of the slides. And in the slides, you'll see I have links to how you could set up your own free tier account. Okay. And I sometimes get the question like, why are we covering AWS at a Cisco user group? It's really more of a networking user group these days, to be honest. But even that being said, Cisco themselves is a huge AWS partner. And so I think there's value in covering it, even if it's not a direct Cisco product. And I'm doing a project right now that involves SD-WAN that ties directly to AWS. So for sure, there are huge amounts of overlap. Okay, we're going to start with the concept called global infrastructure. And when we talk about global infrastructure for AWS, it's the very fundamental building blocks. It's where can you put your stuff and how are those places where you can put your stuff connected, right? So Amazon breaks it down into a couple of concepts. The first one that we need to know about is regions. Regions are geographic areas. So there's a region in Oregon, there's a region in Ohio, there's a region in Ireland, right? There's a region in Japan. There's actually two regions in Japan, a couple of regions in China, right? So a region is a geographic area where AWS has presence. And then the other concept you need to be aware of are availability zones, which I will call AZs quite often in the talk. An AZ is one or more data centers within a region. So if everything we do today, I'm going to demo out of the Oregon region, right? And when we dive in and look at the Oregon region, you're going to notice that there are 4 availability zones. That means there are a minimum of 4 data centers in Oregon dedicated to the Oregon region. They are geographically dispersed enough so that they are not dependent on one another for things like power or telecommunications connectivity, things like that, right? Um, uh, so just keep that in mind. The availability zones in general are highly resilient from one another. So if one AZ were to go down, the additional AZs will remain. There's over 30 regions and over 100 AZs across those 30 regions, right? And again, I have a link in here that you can go check out if you're interested in learning more about the global infrastructure. When we connect between regions, it depends. I mean, there's no hard set, here is the AWS standard, but they are usually connected. The regions are typically connected via multiple terabits worth of networking capacity, right? They kind of famously they run their own undersea cables. So they kind of recently, maybe not recently, I shouldn't say that, but not too long ago, I guess. They opened up a new region in Australia, and I think they added something like 400 terabits per second of routing capability um, between the new region in Australia and the other regions around the world. Now, obviously, it's not a full mesh; it's not connecting to every other region, but to get to the rest of the AWS backbone, they had about 400 terabits of capacity on their WAN link. So it's a pretty significant thing that they do when they're building out that global infrastructure. And I do right away, I have recommendations here. And this is one that often gets overlooked, uh, but it's an important one. And that is um, if um, if you can, you really want to learn the differences between the AWS services and whether they run at the account level, the region level, the availability zone level, etc. How is this service that AWS is offering? How is it scoped, right? So like, for example, Route 53 is a global service. It runs not in a region, it runs in every region globally at once. That's our DNS service, for example, right? When we get into VPCs, those run across an entire region. When I build out a VPC, it always spans the entire region. That means every availability zone has the potential of connecting to that VPC. But then there's other items like ENIs, which might be confined to a single subnet, for example. And we'll talk more about these terms. So let's get into basic concepts. And we're going to start with the VPC or virtual private cloud. And it's effectively the building block, the lowest level building block of a network construct in AWS. It's where you're going to really start for the most part. We'll go into how to design AWS kind of like from a high level. And there are a few pre-steps before you get to the VPC, but for the most part, you're going to start with the VPC. And as I mentioned before, it's a regional construct. That means it automatically is spread across all the AZs in a region. If you're in Oregon and they have 4 AZs, you have access to all 4 AZs in every one of your VPCs. Now, you don't have to connect your VPC to all 4. You just have access to them. So it's up to you what you actually want to configure. There is, by the way, a default VPC in every single region for the most part. So when you create an AWS account, even a free tier account, they will create for you something called a default VPC. I find that they can be helpful when you're just getting started and you just want a sandbox to play around in. But my recommendation, you can see it at the bottom of the screen, is delete the default VPC when you're ready to actually start using AWS or get a little more serious in your learning. The problem with the default VPC is they have overlapping IP addresses in every single region. They're all out of the 172.31 range. And they have internet access, they have permissive security groups. They're really there to sandbox, to just say, hey, if you just wanted to spin up an instance and see if you could browse to a website you just built, you could do it in the default VPC and everything works and you don't even need to know networking, which I get why they do that, but as network engineers and architects, our job is to know about networking. So I would recommend just deleting that default VPC. It only leads to confusion later down the road. I can't tell you how many times customers have come to me and said, hey, I built all these resources and I can't reach them. And then we find out they built them in the default VPC on accident because no one's paying attention to things like IP addresses. And I have to explain to them, well, you're going to have to delete and move all those into your actual production VPC, right? So when we create a VPC, the only thing we need is a CIDR block. IPv4 is mandatory. IPv6 is supported. There are caveats. The caveats actually are not consistent. They will depend region by region. In general, there are fewer caveats. Last time I had to do IPv6 anyway in AWS, much fewer caveats in Asia than there are in North America. Um, and then when we create that CIDR block, it can range from anywhere from a /16 to a /28. You can add more than one CIDR block to a VPC. However, whatever the first CIDR block is that you add, that is called the primary block, and that will be uneditable. You can't change it, you can't delete it, you can't do anything. It is fixed. When you add additional CIDR blocks, you can change them, like mostly you can delete them. That's how you change them, really. Um, This is a difference between AWS and other clouds like Azure and GCP. Both Azure and GCP, um, the CIDR blocks are more malleable. You can add or remove IP addresses from them. We'll talk more about that when we get into subnets and AZs. And then the last thing to be aware of is when we spin up a VPC, there is automatically, we have a little bit of limited influence over it, but we certainly can't delete it or change it too much. There's something called an intrinsic router that's built at the instantiation of the VPC, and it's effectively going to be the default gateway for all the things you put into the VPC. So I promised demos, and we're just going to work right alongside. We're going to create a VPC. You can see I'm in the Oregon region right now. Here's all their different regions, right? Actually, this is not all their regions, but this is all the regions that I have access to at the moment. But we're going to do everything out of Oregon. And you can see we have no VPCs. I mentioned that default VPC. If I swap over to like North Virginia, for example, now, I have not ever built anything in any region other than Oregon, and I build and destroy all the time. You can see over in Oregon, there's already a VPC. I didn't do this. 172.31.00/16. That's the default VPC. If we actually scroll over, it'll say default VPC and it's tagged to yes. That's how you kind of know. You also just know when you see 172.31. Let's come back into Oregon. And let's go ahead and create a VPC. It's going to be pretty simple. So we'll give it a name. We'll give it an IPv4 site. Remember, the IPv4 is mandatory. Okay. And in this case, I will not give it a secondary or IPv6. I'll just do that. And I'll say create. And next thing you know, we have our VPC. Now, remember, VPC stands for Virtual Private Cloud. And indeed, it is truly private. Right now, the way I've built this VPC, it doesn't have any way in or out of the VPC. It's like building a room with no doors or windows. It's just an enclosed box right now. I could build out servers. I could put in uh, uh, code-based infrastructure. I could do all those sorts of things right now, but it could never leave the VPC and nothing could come into the VPC. It would be completely isolated. So we'll get later, we'll talk about gateways and we'll use those to figure out how to get traffic in and out of our VPC depending on our use case. Let me just check real quick if we have any questions. Okay. Yep, we're good. Yeah, you're right. Yeah, and that is a lot of bandwidth, and they run all their own underwater fiber. It's pretty incredible.
Yeah, when you said that, I
Yes.
was like, wow.
So Tiago, it's a good point. In Azure, a VPC is called a VNet. Um, they are they are fairly equivalent. They're very similar to one another. There are some differences between VNets and VPCs, but for them, and we will cover some of those. But a VPC in AWS is a VNet in Azure. Now, GCP also uses VPCs. Their VPCs are fairly different. I mentioned, for example, that in AWS, a VPC is regional. It's built across a region and it has access to all the AZs in the region. In GCP, a VPC is actually a global object. When you build out a VPC in GCP, it actually spans all the regions across the globe for Google, right? And then you can tag in things like projects and accounts that might be regional, but the VPC itself is global. So that's pretty different. Also in Azure in VNets, you have this concept of like paired regions, and there is no concept of paired regions for your VNets and other resources in AWS. That's an Azure thing. Okay, so once we build our oh, there was another question. I'm so sorry. I think it came from a good buddy, Charlie, too. Are all definitions private IP? So I'm just gonna say let's wait on that one, Charlie, because we're gonna cover that uh, later in the talk, actually. But all your all your IP addresses that you assign to things are going to be private, and then we have a whole slide to talk about NAT options for getting to and from the internet. Yeah. Once we build our VPC and add in our CIDR block, the next thing we do is we add subnets. You can probably see a trend already forming. We build this out pretty similar to how we might build a new network at any of our locations, right? We start out with the IP stuff. We start out with the IP plan. This site's going to get 10.1.0.0/16, and then this building's going to get the 10.1.0.0/23 network. And this building's going to get the 10.1.2.0/23 network, or however we want to break it up, right? And then we start laying it out. We might say like, okay, the VLANs in building A are going to be like this. The VLANs in building B are going to be like this. Very similar concept in AWS and any of the other clouds. So the subnet is an availability zone level construct. That means that when we talk about a subnet, it is tied to exactly one and only one AZ, right? This is a significant difference between AWS and the other two major cloud providers or infrastructure cloud providers. In Azure and in GCP, subnets span all the AZs in a region. When we get into what I call putting it all together with some designs, you'll see how that makes a big difference. But just keep in mind, there is always a hard layer 3 boundary between availability zones and subnets. Even if the subnet object itself is in the same AZ, these could both be an AZ1, for example, but it's still a separate subnet. You can't overlap your subnets. So there is no layer 2 spanning up in these subnets. It's all layer 3 only. And every subnet you create is auto-attached to the intrinsic router. We talked about that intrinsic router, and we'll talk about it more throughout the evening. But every subnet I create gets auto-attached. That's not something I can affect. It just happens, right? It just happens that you will auto-attach. And your default gateway will be set to the first IP address of your subnet. So over here, the default gateway is 10.1.0.1. And guess what has that IP address? It's the intrinsic router. You don't have an option there. I say you don't have an option there. We do have some interesting, more advanced things we're not going to get into tonight with certain types of load balancers and stuff like that. but your default gateway, generally speaking, will always be the intrinsic router, and you don't, generally speaking, you can't really change that. Okay, and now if we come back over here, we have our VPC. Let's create our subnets. So the first thing we do is we select our VPC. I am a big fan of names, by the way, and one of the other first things I would recommend is come up with a naming standard for all your networking objects. I find that a lot of the application developers and so forth, they are less concerned about names. They manage things through these items called tags, and actually a name is an example of a tag. But I find that network people, a lot of times, they like to see a name, just like on a router or a switch or an AP or a firewall, we like to see a host name, right? So I would recommend coming up with some kind of naming standard. Now, availability zones, remember it's a subnet equals a single availability zone, or AZ, right? So here you can see that my US West is broken into 4 AZs, right? You can see 2A, 2B, 2C, 2D. And underneath, you'll find an availability zone identifier, and you'll see that US West 2A maps to USW2-AZ2. So this is, I'm not going to spend a lot of time on this, but it's a weird thing to kind of wrap your head around. But in AWS, on an account by account basis, they randomize the AZ name. So for example, if I spin up my own account, we'll all have 2A, 2B, 2C, 2D up in the Oregon region. My 2A maps to AZ2. My 2B maps to AZ1, for example, right? Now, if Tiago creates his own account, he may well find that his 2A actually maps to AZ1, and his 2B might map to AZ3, and then, so forth. Amazon does this to try to help randomize the distribution of consumption of services. What they don't want is someone sees a drop-down list and they just automatically pick the first thing in there because it's the first thing in there. And then all of a sudden, everyone is all of a sudden in the US West 2A availability zone, and they've run out of EC2 space or something like that, right? So instead, what they do is they have an availability zone name, and it always has a letter, 2A, B, C, D in this case. And then they have an availability zone identifier, 1, 2, 3, 4 in this case. The AZ name is randomized on a per account basis. The AZ identifier is absolute across all accounts. So if Tiago and I both set up VPCs and we want to keep everything in the same AZ for, say, performance reasons, I don't want to give him my AZ name. I want to give him my AZ identifier. I saw a question pop up. What is EC2 space? EC2 is we're going to get into EC2s in a little bit, but that's a compute. It's not a space thing. EC2 is like a VM, and EC2 is the same as a VM effectively. And we're going to spin up some EC2s towards a little bit later in the demo, like towards the end. So for sure, we're going to cover EC2s. I might have said AZ space or IP space or something, or if I said EC2 space, that's just a misspeak. And EC2 is the equivalent of a VM. So I need to, you can see the CIDR block that I have. This just comes straight from when I picked the VPC to put my subnet in. And now I need to give my CIDR, or sorry, now I need to give my subnet object its own sub-CIDR block off of that. I could consume all the IPs in a single subnet, but if I want 2 subnets to go across 2 AZs to improve like resiliency of my solution, I might want to break it up. So In this case, I'll do 10.1.0.0/24. That's a subnet off of the supernet of the CIDR block. And now we'll create a second one. This one I'll put in the 2B availability zone, and I will give it 10.1.1.0/24. And now I will create it. So now we have our VPC is created, and you can see that we have two subnets also created. Those subnets are auto-attached to the intrinsic router. There's really nothing we can do to change that or affect that. There's nothing in the subnet, so there's nothing that we can see either. And let's go on to the, oops. Now let's talk about route tables. I'm not going to cover route tables in the console yet. We'll get to those in a little bit when we cover a few more slides. The route table is exactly what you would think, right? The intrinsic router doesn't really directly support dynamic routing. There are other what we call gateway objects that may support dynamic routing, which can possibly update the intrinsic router automatically. But the route table itself is static routes. It's a VPC level construct, meaning if my VPC spans all AZs, now I might not have subnets in all AZs, but I have the potential to create subnets in all the AZs, then that means my route table also has access to all AZs. And again, it might be that I don't use all the AZs, but I have access to them. There is a default or what they call a main routing table, which is created at VPC instantiation. I will show that real quick. You will see that there is a route table. I didn't create this, right? You can see under main, it's tagged yes. My recommendation here is do not use the main routing table. Instead, create dedicated routing tables. And we're going to talk about that. First of all, in the routing table, you will always have an entry for the CIDR block of the entire VPC. That's not negotiable. It's just in there and you cannot change it. You have the ability to explicitly associate a subnet with a route table. And this is a very common recommendation. It's down there in my recommended as well. I recommend that when you create your routing tables that you come in and manually and explicitly associate a subnet or subnets with the routing table, right? What is that main routing table or default? Right, it's really the main routing table, but it's also default because it's just built for you. What it really is it's a catch-all so that any subnet that's not explicitly associated with a routing table is implicitly associated with the main routing table. Okay. The other thing to be aware of in routing tables is unlike on a Cisco router, your next hop will not be an IP address. It's going to be an object. That'll make more sense in a few minutes when we go do the next step in the demo. Let's talk about security. This is always a top concern. Now, remember, right now, we don't really need any security because I don't have any way in or out from my VPC, but we're getting pretty close to when we're going to add ins and outs to our VPCs. And security is always a top concern, as it should be, absolutely. And we really have, on the network side of things, there's a lot of different security mechanisms in AWS. But on the network side of things, we have two main ways that we conduct our security. We have something called NACLs, or Network Access Control Lists, and security groups. NACLs are attached to a subnet object. 1 second, please. Sorry about that. NACLs are attached to a subnet object, and they impact or affect everything that is in the subnet. right? They are also not stateful. So I need bidirectional rules manually added, right? If I want 10.1.0.0 to initiate into 10.1.1.0/24, I will also need a reverse rule that allows 10.1.1.0/24 to initiate over into 10.1.0.0/24. As such, and you can see it down at the bottom, I typically do not use NACLs. They're not granular enough because they apply to everything in the subnet kind of indiscriminately, and they're not stateful. So they're not terribly um, scalable from that perspective. Security groups, on the other hand, are kind of the opposite. They are stateful. And security groups run at the what we call the ENI or the VNIC level, right? Basically, your network card on your VM, right? And so you can kind of see, hopefully you can kind of see this. There's a NACL that is attached at the subnet, and it inspects traffic as it enters or enters and leaves the subnet. However, the security group is attached down here on the actual VNIC of the VM or the EC2. And over here, you can see I have some other EC2s. They're in, even though they're in a totally different subnet, they're in the same security group as this. So that means that they can freely talk to one another. However, if one of these EC2s down here wants to try to talk to this ENI up here, it would be denied because unless there's an explicit rule that was somehow written. They don't have to be in the same security group, but there has to be a security group that would permit it. Security groups in general are permit only. Anything not explicitly permitted is implicitly denied. So very similar to an ACL on like a Cisco router or a prefix list on a Cisco router, right? We're all probably pretty familiar with that. And you cannot launch something like a server or an EC2 in AWS without associating it to a security group. So another good best practice is do not allow your users to make overly permissive security groups, meaning don't allow them to do something like permit any, right? If I'm in a private VPC, for example, maybe I only allow in RFC 1918 address spaces that my company uses. If my company is all addressed out of the 10/8 network, maybe my base security group is permit, 10.0.0.0/8, any port or protocol, but that means no one from the internet could ever get in, at least, right? And that might be, by the way, security groups are additive. You can have more than one security group on a resource. And so you might say that's the base level security group that goes on every one of my private VPC instances. And then I could ratchet it down from there. I could add additional security groups, or I could edit that particular security group or something along those lines. So I recommend security groups over NACLs. NACLs do have their place for sure. I just don't use them as often as I use security groups. Okay, gateways. I mentioned we were going to talk about gateways. These are the different ways we might get in and out of our VPC. But really, in a more general sense, a gateway is any routing object. It doesn't have to be a dedicated router, right? ASAV is a gateway because it has routing capability on it. A Meraki VMX is a gateway because it has routing capability on it. Okay, or some of the other AWS gateways. Let's talk about some of the common ones. There's way more gateways than this, but these are some of the common ones. We have customer gateways. Customer gateways are routing objects that you manage and own, not AWS. So for example, if I deploy an ASAV or a VMX into my AWS account, it's actually deployed as a customer gateway. It's a router that AWS does not own. Likewise, if Jan decides to build a VPN from his VPC down to his FTD firewall or his PAN firewall at his corporate HQ or at his data center, that PAN firewall is a customer gateway. It's a routing object that talks to AWS that AWS doesn't directly control. Transit gateways, we're going to have a whole slide on transit gateways, but these are an ability that allow you to route between VPCs. So you could have more than one VPC. In fact, I'd say it's very common to have more than one VPC, and they have a limitation where they don't transitively route. We'll talk more about that in the transit gateway section. But the TGW allows you to route between all of your different VPCs in a particular region. Internet gateway, this kind of gets into what Charlie was asking about. We do have the ability to get to and from the internet directly from our VPC, right? And we'll go through one of our designs is going to involve internet gateways, by the way. So we will go through these in the design section, and we'll go through them in the demo. It's exactly what it sounds like. It's just a routing object that allows you to connect your VPC to the internet. We have something called virtual private gateways or VGWs. This is a VPC. This is a little more specialized. You don't necessarily need the internet for this, but it's a VPC product operated by AWS, and it's used to terminate IPsec tunnels to a customer gateway. So when I talked about maybe Jan wants to set up an IPsec tunnel between his VPC and his on-prem PAN firewall, he might want to do that through a VGW or virtual private gateway. Okay, so it will still use the internet, but you cannot use the virtual private gateway as a replacement for an internet gateway. It only talks IPsec. That's all it does. So it's predominantly used for connecting our on-prem to our cloud. And then we have a direct connect gateway. Now, a direct connect is a private circuit like dark fiber between you and Amazon. And a direct connect gateway is a way to tie that circuit or those circuits, if you have more than one, into a routing object that then can route to different things in Amazon. Like if you want to route your direct connect traffic up to your transit gateway, so I'm not doing VPNs, instead I've got high-speed fiber, I would use a direct connect gateway. A direct connect gateway terminates my circuits from my on-prem, from my customer gateways, and it also has a connector into the transit gateway. Also, I can have direct connect circuits in a single region and share those out through the direct connect gateway to other regions. So let's say I have direct connect circuits up in the Oregon region. I could spin up a direct connect gateway and then connect it to VPCs in, let's say, the Northern California region, so that the Northern California region can take advantage of my direct connect circuits. My general recommendation here is anytime you're working in AWS, and specifically if you're talking to AWS folks and they start talking about gateways, you want to be sure to clarify or ask clarifying questions about what gateway are they talking about. Are they talking about a customer gateway, transit gateway, internet gateway? What kind of, there's so many gateways. We are definitely not covering them all here. So, 1 second. We just talked about this, the VGW or Virtual Private Gateway. As mentioned before, it's exclusively used for terminating IPsec tunnels, right? So if you wanted to create a site-to-site between your on-prem and your VPC, you could do so through a VGW. It's a pretty limited object, I'm going to be honest. It does what it does, and it's not a terribly expensive way of doing it, but it's very limited in its capabilities. It has some impressive capabilities, but there are some difficulties. let's kind of go through those, right? Um, you can do either static routing or BGP, but you need to be careful because there's a default of 50 route limit. Uh, and although it's listed here as on your VGW, the route limit is actually on the intrinsic router, right? If you can raise it from 50 to 100, but an intrinsic router can never go above 100 routes. So if you're running BGP, you need to do things like send it a default or send it summary routes because you can blow through that 100 routes pretty quickly. Um, it has an encrypted throughput max of around 1.25 gigabits per second. That might be plenty for you, but I have plenty of customers these days that that's not near enough, right? Especially if they're terminating multiple VPNs in there or something like that. It gets divided up. It's not 125 gigs per VPN. It's 125 gigs for the BGW. When you create your customer gateway and then you create your uh, site-to-site VPN in AWS, they will give you the option to download a pre-built VPN configuration for your side, your customer gateway, right? Like, what do I want to paste into my ASA, or what do I want to configure my Meraki like, or whatever, right? My PAN, my FortiGate, whatever it is. I find that those pre-built configs, they're pretty good, but they're not infallible. Also, I should warn you, there is no real way to troubleshoot a VGW. If your IPsec tunnel is not coming up, you're going to be relying on troubleshooting on the customer gateway, not the VGW. If you have a support contract with AWS, you can open up support tickets with them. They can get more advanced looks at the VGW, but even they have pretty limited view in there. So it's a handy gateway, but it's not the most powerful way to do things. That being said, it doesn't cost a lot. I think the VGW is free. You pay maybe per gigabyte of encrypted traffic going through it, and that's I think how they charge you for it. We mentioned TGW or Transit Gateway earlier. This is one of my favorite constructs. This is pretty unique to AWS. So if you're from Azure side of things, they have something a little bit similar called a vWAN hub. It's not really the same thing. A vWAN and a TGW are not really equivalent. Um, I find the TGW to be more flexible and powerful than the vWAN. And they kind of solve different problems, to be perfectly honest with you. I mentioned earlier that VPCs in general do not support transitive routing. That means if I've got 3 VPCs in a region, A, B, and C, and I can route from A to B, and I can route from B to C. However, A cannot route to C through B. Okay? Effectively, B will drop all of A's traffic that's destined to C because it says, well, let's go into an IP address that isn't in my CIDR block. So from a security standpoint, I just drop it. There is no transitive routing in most VPC mechanisms. However, we can get around that with a TGW or transit gateway. That's what the transit means. Now I have 3 VPCs, A, B, and C. I connect all these VPCs into my transit gateway, and then which is not in a VPC, it's a regional construct, so it spans an entire region, and it has its own routing table, and it knows through this thing called these little lines that are drawn that are connecting into the TGW, they're called attachments. And if this is VPC A, VPC B, and VPC C, it'll say, okay, a packet's coming from A and it's going to C. It just says, oh, to get there, I go through attachment C, and it just sends it out its attachment. So the TGW solved a lot of problems for not just transitive routing, but also for scalability. Remember that the intrinsic router in the VPC can never hold more than 100 routes. That's the hard limit. The soft limit's 50. The TGW, I think, can hold 5,000 routes, so it holds a lot more routes. Um, it does do both static and BGP. There are some limitations with the BGP on the TGW. BGP is supported only through certain kind of attachment types. Not all attachment types support BGP. The transit gateway has the ability to create multiple route tables so you can get more advanced routing behaviors. I wouldn't call them VRFs. I would call them kind of VRF similar, right? So I could have an isolated VPC that has a separate routing table from all the other routing tables on the TGW or something like that, right? These attachments connect directly into the subnet of the VPCs. A lot of people will, and I'll be one of them. I recommend you dedicate a subnet for connecting that TGW. This provides you some routing flexibility. Like, for example, if I have a HA pair of firewalls, it allows me to kind of keep the traffic always going to the primary firewall, not the secondary firewall, and things like that. If I need to make routing decisions, because remember, I can build routing tables per subnet if I want and explicitly associate them. It gives me a little more flexibility for routing my traffic in and out of the VPC when I have what I call a connection subnet. So that's a recommendation. Also, as mentioned before, the TGW supports BGP. And so I just want to point out, even if you don't have a BGP use case today, I strongly recommend you assign a BGP ASN. A private ASN is totally fine, to your TGW. The reason I recommend that is you can't do it after the fact, right? So if you're deploying today, if Charlie is building a TGW today and he's like, well, I don't really ever need to run BGP on this, so I just won't give it an ASN. If 2 years from now, Charlie's like, okay, well, I need to run BGP on it now, he would literally have to delete and rebuild a brand new TGW, which means all of his VPCs that were connected are going to take a hard outage. So just avoid that and assign a BGP ASN. Again, a private ASN is fine. We don't connect these things to the internet. And just give it a private ASN, and whether you use it or not, at least it's there and you won't lose any sleep if you have to change it later on. Let me just pause for a second, see if there's any questions. Nope, looks like we're pretty good. Okay, let's talk about IGWs. This is an internet gateway. And this gets a little more directly to your earlier question, Shirley, about is everything private or can I also have public? Internet gateway opens up the concept of private and public. Okay. So I could have two subnets and I could call one public and one private. And in fact, you'll see a lot of AWS designs that do that. In AWS parlance, a public subnet means everything in that subnet has a NAT associated with it. You can deploy an IGW, but if you don't have a NAT, you can't go out. The IGW will drop any traffic that's not NATed to a public IP. Okay? So again, the IGW, it will drop any traffic that's not NATed to a public IP. So the public subnet are all the things in your VPC that have a public IP. And we'll get into NATs in the next slide and how they kind of work, because there's a couple of different ways to do it. When we're creating the IGW, it couldn't be simpler. We're just going to create an IGW and then we're going to attach it to our VPC. It doesn't run any routing protocols. It's just there for default route. We'll then go back and program in a default route into our route table, right? The IGW is redundant across the entire region. So it's in every single AZ. So if your VPC, which also is across the entire region, also spans every AZ in the region. But if you only have subnets in 2 of the 4 AZs up in Oregon, then your internet gateway is only redundant across the two AZs you have hosts in. It doesn't do you any good if I'm in AZ1 and AZ2. It doesn't do you any good that this internet gateway also touches AZ3 and AZ4 because I don't have any resources in AZ3 or AZ4. Now, if I wanted to, I could always expand and add more subnets into my VPC and add in AZ3, AZ4, and then I would have that redundancy. But it's automatically redundant. You don't have to do anything. If there's an outage in AZ1, your internet gateway stays up and functional. It does what they call auto-scaling bandwidth. And I believe on the IGW, you just pay for the bandwidth that you utilize, like a per gigabit per second. Sorry, no, I think it's a per gigabyte charge, not per second, just per gigabyte that goes through the IGW, I think. It auto-scales to bandwidth. It does max out though. I think the max on an IGW is currently 45 gigs. If you need more than 45 gigs to the internet, you need to talk to AWS, and I think they have a few custom solutions that they can do. Any given single session, however, has a max bandwidth of 5 gigs. Can't go above 5 gigs on any given single session. As mentioned, if we have an IGW to get my traffic out of there, I have to do NAT. There's 3 primary ways to NAT in AWS, but we're only going to really want to use 2 of them. The first one I'll deal with and discard, and that is something called auto assign. You can, when you spin up a host, you can choose to auto assign it a public IP address. I don't like this method, and I don't typically recommend it. The reason being is it can literally only be configured at instantiation of an EC2 instance. Once the instance is up, you cannot auto assign a public IP. You can't change it afterwards. You have to make that call before you spin up the instance. The other larger problem, in my opinion, is the IP is not permanent. Anytime you reboot, shut down, and bring back up, or anything else, that server, the public IP will change, which makes it difficult to have a public-facing service when your public IP is changing. You could do fancy things like writing dynamic DNS records or something like that, but we have a better option, and that's the elastic IP. That's the way I prefer. If I'm going to have a single machine or EC2 that needs public internet access, I will give it typically an elastic IP. We're about to go through a big lab where we do all these different things, so bear with me. And so what I will do is I will allocate an elastic IP, then I will associate it with an EC2 instance. If that EC2 instance has a single ENI or VNIC, then it's very simple. That one VNIC is what gets the public IP. If I have an EC2 that has like 4 VNICs or something, I need to pick which particular ENI gets the public IP address or the elastic IP. So that's how I do the assign. The elastic IPs are bidirectional, meaning I can NAT out the IGW, but the internet can also NAT in and talk to my EC2. Now you can protect it by putting in things like a security group. You can even protect it by putting in things like a firewall. You can put in an ASAV or an FTD or a PAN or a FortiGate or whatever firewall you want, right? Meraki VMX. So you have the ability to put it behind a firewall. You have the ability to put a security group on it. You can do all sorts of things to protect it, but you should be aware that when I do an elastic IP, the internet in general can come in and try to hit that public IP address. The other option, so this is a one-to-one. An elastic IP is basically a one-to-one. It attaches to a VNIC, and it says, this IP under the VNIC nets to this IP on the IGW. What about my private subnet when I want all my systems in my private subnet to be able to go out and say patch or something like that? Yeah, you could do something similar in Azure, Charlie. You can definitely put, I mean, we have a couple of customers that do ASAVs or FTDs up in Azure. So you can do the fire. The way you do it will probably be a little bit different, but in fact, it is different. The way you do it is different in Azure versus AWS, but the concept still carries back and forth. Good question. If I want to have like all my private hosts be able to go out to the internet, like for patching or, uh, maybe I've got a bunch of VDIs over here and I need them to watch Jason present at SCUG or something like that. I need them to be able to NAT, right? So for that, we use something called a NAT gateway. It's another gateway device, right? And a NAT gateway is a many-to-one NAT. So I will have many private hosts that go to a single public IP, and it's a one-way NAT, right? The internet does not get to come in and hit a NAT gateway. The NAT gateway, it's a custom AWS object, and when I deploy a NAT gateway, the IGW knows I don't allow the internet to initiate connections into my NAT gateway. That's not allowed. Outbound, all day, every day, it's fine. And again, it will do a many-to-one NAT. The NAT gateway, however, does have some limitations. It is in a single availability zone. It's a availability zone or a subnet spanning object. So if you want resiliency in your NAT gateway, to go beyond just a single AZ, you may need to deploy it in more than one um, availability zone. Let's come take a look at this in the console. There's a lot of information, so let's have a little fun now. Let's come down and create an internet gateway. Call this my IGW. Okay. I need to, once I create it, I need to attach it to a VPC because I could have many VPCs. So I say this one is actually going to attach to this particular VPC. I've only got one VPC in the region, so we're good. And I get a success notice. You can see it's in a state of attached. At this point, I've got my subnets. I have obviously I have my VPC, I have my subnets, I have my IGW. Now let's go ahead and add in routes in my routing table. Now remember, this is the main routing table. I don't recommend using the main routing table, so I'm going to go ahead and create a routing table. I will select the VPC I want it to be affiliated with. Now remember, the main routing table, you can see this is already tagged as not main, right? That means the main routing table means anything not explicitly associated with this routing table is implicitly associated with the main. So the first thing I'm going to do is come in and manually or explicitly associate my subnets with this routing table. And then I'm going to add a route. I come in and edit routes. I add a route. It's default route. I'm going to point it. Remember, we don't point to IPs. We point to objects. In this case, I'm going to point to an internet gateway. I only have one internet gateway, so I point to that. Okay. So now I have my VPC, I have my subnet, I have my internet gateway, and I have my route table, right? Make sense? Pause real quick and see if there's any questions. Okay, I think I'm all caught up. So I mentioned before that if we're going to launch instances, we have to apply a security group. I can come in here. You can see there is a default security group. If I come down and look at it, outbound rules are typically always permit any. These are stateful. So it's mostly looking at the inbound rules. What do I allow to talk to my instance? And you can kind of see it basically says, if the source is within the security group itself, then go ahead and permit all traffic. So it's just allowing all the hosts in the security group to talk to the other hosts in the security group, which is okay, but we want something a little more, right? So I'm going to create a security group and I'm going to call it my ICMP security group. Allow ICMP. I need to say what VPC has access to the security group. And then I need to add some rules in. So I'm going to add a rule that permits ICMP. In this case, I will allow anything IPv4 because I want to be able to ping it from the internet. Okay. So that's the only rule. You can't SSH or web browse to this thing. But when we create our instance, we're going to be able to ping it, right? That's all it's doing. And this is a little weird. You can see that there's something called security group name, but this is actually not the object name. It's a different field. If I come all the way to the bottom, I can add a new tag, and I can do a capital N name tag and call this like my ICMP SG. And this will actually name the object. You'll see that in a second. Okay. So here is the default security group, and you can see it doesn't have a name in this column. It has a name only in this column. If we scroll up, you can see my security group name and my object name actually match. And security groups aren't the only kind of inconsistent item in AWS that kind of works this way, where sometimes they have a name and sometimes they don't. I recommend everything get a name, so I just manually put in the tag of name and give it a value of something, in this case, my ICMP-SG. So now, if I deploy a server, I should be able to ping it at least. So let's go ahead and do that. Whoops, I did not want to do that. I wanted to move this over. This is an important thing when you're working in AWS, is you want to get used to right-clicking and opening a new tab. This way I can have multiple tabs open and I could look at, for example, my VPC and my EC2s, or my EC2s and my load balancers, or my load balancers and my DNS. So open everything in its own tab. So currently I don't have any EC2s or instances running in here. So let's go ahead and create one. I'm going to launch an instance. My ping EC2. I'll just keep it on Linux for right now. So remember I mentioned at the very beginning, I'm using what's called the AWS free tier. And you can see as long as I'm sticking to this T2 micro, I am free tier eligible. Right, so I'm going to want to stay to something free. There are other options for free tier eligible, by the way. If you scroll down, you'll find there will be some other options. It depends on the OS you pick. But I always do T2 micros. Key pair for login. This is so that in this case, I don't have SSH opened on my security group, but if I wanted to, I have to have a key pair. I only get one chance to create the key pair. So in this case, I've actually already created a key pair from yesterday's demo that I did. I could create a brand new key pair. I'm just going to say, hey, I'll use the one I already created. I already have access to that key, so I can SSH in. Okay, let's take a look at the network settings, right? It's only got one VPC to pick from, right? It has two subnets, though. Let me come back to my drawing real quick. And here I said my 10.1.1.0/24 is going to be my public subnet. So this is currently in 10.1.0.0/24. Let me move it over to my subnet 02. Okay, so that's where it's going to put it. Here is that auto assign public IP. We're going to leave it disabled. Under security group, remember you always have to attach a security group. I will do select an existing one, and we'll pick my ICMP SG that we created. There are other things we could do down here, but that's everything we need. And here's my instance. It'll take a minute to be able to come up and work. So I cannot ping this yet because it doesn't have a public IP. So what did I mention? If we were going to put it in the public subnet, it gets a NAT. The NATs are called elastic IPs. This is a one-to-one NAT. So the first thing I do is I allocate. It didn't let me name it, so I will do a capital N name here and do my EIP for elastic IP. Once I allocate, I actually need to associate it. I need to say, now that I've reserved this elastic IP, what's it going to apply to? In this case, I will apply it to an entire instance because my instance only has one ENI or VNIC. If you had an ENI, or if you had an instance that had multiples, you could associate it with a network interface instead and pick which one of the interfaces. So if you had an FTD firewall or a FortiGate firewall or something like that, that had an inside interface, an outside interface, a DMZ interface, a HA interface, or something like that, you could say which one gets the public IP or the NAT. I need to pick an EC2. We'll pick this one. Obviously, it's the only one I have. And now I hit associate. This is the IP address I was given. Let's go ahead and see if this works. If I've done everything correct, we're going to cross our fingers that Jason's live demo actually works. Oh, let's come back here real quick into my instance. Okay, it says it is running. Here's my public IP. You can see that it's a public IP because and an elastic, right? Let's go ahead and look at the instance itself. Here's its private IP. However, it's not allowing my pings in for some reason. 228164. Okay, this is what happens with live demos. I won't spend a lot of time troubleshooting this. We don't have that kind of time, but let's come down. This is my security group. Oh, I did this yesterday in the demo as well. I accidentally added it to the outbound rules. I need an inbound rule. So I'm going to edit the outbound rules. I'm going to add a rule. I should have known because it had a permit any. And permit any is kind of the hallmark of actually yeah, let's change this to all traffic. That's what I want to do. I made the exact same error yesterday, but that's okay. This is how we kind of learn, right? So I actually want to inbound. Why inbound? Because it's coming from the internet in through the IGW to the instance. I'm going to add an inbound rule, ICMPv4. I'm going to allow it from here. I'm going to hit save. And now hopefully this is going to start going through in a moment. Let's come back to my instances. And sure enough, here you can see all I did was update the security group. I made the exact same mistake yesterday. It's funny. But you can kind of see it's all working now, right? So, and I want to pause for a second and think about everything we just did, right? we just created basically what could be our new data center. We created our subnets. We created our internet routing. We created our NAT policy. We created our ACLs to protect our instances. We did all that, and we did it in the space of about an hour and 15 minutes. That's pretty good. Yeah, exactly. Right, Charlie? That's not bad. Okay, let's come on back in here. We'll be wrapping up in the next 15. There's one more secondary and teaching at the same time. Yeah, well, that might be debatable, but I'm trying to teach. I'm trying to do my best anyway. Um, let's talk about one additional item, and it's called VPC peering. I don't use this a lot, but there is a specific use case that it is so important to be able to use it for. So before the transit gateway, if you wanted two VPCs to talk to one another, there are only a few ways you could do it. There was this thing called a transit VPC. In 2018, I gave a full 2-hour lecture at Cisco Live to go over this. Um, so one second, I saw something pop up. I want to make sure I don't miss any questions. Oh, okay. So thank you very much, Andrew, because I'm of the same mind. I'm of the mind that going through and watching someone who's done something 100 times and it doesn't work out, and then seeing their troubleshooting methodology, I see value to that. Not everyone does. Some people are a little more touchy about that than others. I make mistakes every day. I fix mistakes every day, thankfully, as well. So thank you for that feedback. I do appreciate it. So, but the main way that we would get traffic to between two different VPCs is with something called VPC peering. You don't see it as much anymore. The transit gateway really got rid of a lot of VPC peering, but it's a way to basically route directly between two VPCs. And the important thing is only between two VPCs. Okay. You can't do this transitively. I can't add another VPC peer over here to the right of this one and then have this one route through this one to this one. No transitive routing and VPC peering. But if you just need point-to-point communication between two VPCs, VPC peering works pretty well because it's not very expensive and it's effectively infinite bandwidth. Now, there is no truth such thing as infinite bandwidth, but it's as infinite as we're going to get in AWS. So, oops, sorry about that. It's about as it's just about as close as we can kind of get to infinite bandwidth with this VPC peering, and it's not terribly expensive. There are limitations. The biggest limitation is my CIDR blocks cannot overlap at all. Now here you can see one CIDR block is 10100/23, the other CIDR block is 10120/23. No overlap. I can peer these all day long. However, if I have overlapping CIDR blocks, it doesn't matter because you could put a /32 into your routing table and point it to the VPC peering object, but what's in your routing table doesn't matter. If it doesn't pass the CIDR block test, it doesn't allow you to create the VPC peer. Until you create the VPC peer, you cannot edit the routing table. So that's the biggest thing to be aware of in these VPC peering situations. They're great when I have to migrate or transfer gobs of data between two VPCs because they're inexpensive and they have very high bandwidth and throughput. However, be aware you cannot overlap the CIDR blocks and you cannot transitively route through. I can't route from my on-prem up here to this VPC and then try to reach from this VPC over to this VPC. I need to be able to reach both VPCs from my on-prem, for example. Oops. So we're wrapping up now. Let's get into some general design considerations, and then we'll look at two specific designs. And I can't design your AWS, but I can talk about some common design themes, right? And that's what we'll get into in the next two slides. But let's talk about general design considerations. My number one thing I recommend to you, and this goes against all the clouds. I don't care if it's Azure, GCP, Oracle, AWS, any of them. Start by thinking of your cloud environment as an extension of your company. It's just one more data center, or maybe it's your primary data center, right? Maybe currently you're in an expansion and you don't have a data center. You just have an MDF in your building that has some servers and some extra telecommunications equipment in it. And you're like, we really need to get out of here. The power isn't very resilient, and we don't have multiple carrier options in the building, and the cooling isn't keeping up with things or whatever, and maybe your company says, let's put it up in AWS, and again, or Azure or GCP. I'm just kind of an AWS wonk. So you want to start by putting yourself in the mindset. Um, that's what, yeah, I think you mean express route, Charlie. But if you mean express route like private circuit, yes. That is what I mentioned earlier, direct connect. That's the dark fiber or the private circuit between you and AWS. You can use direct connect. It's the same thing as an express route in Microsoft. I can't remember what they call it in GCP right now, but they have a similar concept as well in GCP. So you want to start by treating your cloud environment as if it were just an extension of your company, right? And sometimes people are like, yeah, except it's not, right? I'm on someone else's hardware. I need all this extra security. You really don't need extra security. What you need is good security everywhere, whether it's at on-prem data center that has internet edge, or whether it's at your CEO's house who has internet like pulled directly to their house or something, or whether it's AWS with an IGW or something. So you want to start by thinking of this in terms of this is another location for my company. It just happens to be this location. It's more like a colo. It's just a colo that I don't even own the servers in, right? And so what does that mean? It means we start with things like IP addressing. And then we move into subnets, and then we move into routing, like our gateway objects. We move into internet access, right? DNS. We didn't cover DNS, but very much. I talked a little bit about it, but there's a whole DNS. That's where I went a little sideways yesterday, so I took it out from today so we didn't go over. Segmentation, things like that, right? All these things you could apply directly if you were building a new data center at a colo at Equinix or something like that, right? You would start with, okay, I need a supernet, and then I need to break that supernet down into subnets, right? And some of those would be VLANs, some of those would be point-to-point, some of those would be loopbacks. I can have similar concepts up in the cloud. Not loopbacks as much, but those other things for sure. I need to have a routing design, right? How am I going to get between my different So that's a little bit beyond what we're doing here, Charlie, but if you want to bring your own public IP addressing into AWS, you can. They have a concept called Bring Your Own IP, and if you just Google AWS BYOIP, you'll get the basic design document around it. I'm going to be honest, having done it, it is a little bit of a convoluted process, but you can bring your own public range into AWS if you so desire, for sure. Um, and I can try to find the link. Definitely don't have it in the slides tonight. It's definitely a more advanced thing. You're going to have to get a little familiar with the AWS CLI. You're going to have to understand how to register certain things certain ways in Aaron, because you're going to have to effectively allow your range. You're going to have to allow your range to be advertised not by you but by AWS, right? So if you have like a /26, you want to move up there or something like that, or 25 or whatever range you want, a 16, it doesn't matter. You're going to have to allocate that. So, um, but you can see a lot of these general design thoughts, they line up just the same as if we were building an on-prem data center or a colo data center. Very similar. And then you need to get into some specifics. What's your HA look like? What's your DR look like? What's your performance requirements, right? All these will then determine like what regions do I go into? How many availability zones do I go into? Do I need to be in multiple regions? Is it sufficient to be in a single region? Just break it up across different availability zones. Maybe I need most of my VPCs to be highly available across multiple AZs, but maybe I have an HPC cluster that's there just for high-speed processing, and they don't even want to take the 2 to 3 millisecond delay between AZs. Maybe I have a special VPC just for HPC clusters that I have one subnet in one AZ so that my HPC cluster uh, can perform at its best, even though it may not be as highly available, right? I have done that before. Um, we didn't go through load balancers. Again, I can only go through so much in an hour and a half, but there's all sorts of load balancers. They've got 3 or 4 different types of load balancers up in AWS. Um, all good general design considerations. Let's look at uh, two potential designs here. One is I've got a regional design. I've got 3 VPCs that might have my apps in it. And then I have a 4th VPC, what I call my inspection VPC, that has a pair of firewalls in it. And you'll notice that's the only VPC that has an internet gateway. So how does this work? It works with a transit gateway. So I build a transit gateway which spans the entire region, and it doesn't sit in a VPC. All of my application VPCs just have a default route that points to the TGW. The TGW says, well, if you're trying to route from, VPC A to VPC C, you just come in on attachment A and go out on attachment C. However, if you're in attachment B, for example, or VPC B, for example, and you want to go to the internet, you route from VPC B down to the TGW. Your default just points to the TGW. The TGW says, oh, well, if you want to go to the internet, you have to go through attachment D, which is my inspection VPC. And then maybe I have an HA pair of firewalls in there. But how do we do HA for firewalls when we deploy them on-prem or in a data center? We do them with layer 2. We run a cable between them, or maybe a cable through a switch or something like that, but they're all sharing subnets. But we have this limitation in AWS that when I put them in different subnets and different AZs for true HA, that's a layer 3 boundary. So right away you have this question of how am I going to do this, right? Assuming that we're active passive, most firewalls are still recommending active passive. They do have active options. We didn't go through it. It's a special kind of load balancer you use. But if it's active passive, the first thing you need to know is you're going to have to go work with your specific firewall vendor to find out what their recommendation is for cloud-based failover within a VPC or a VNet or whatever, right? So, if these are Meraki VMXs, you're going to reach out to the Meraki team. If these are FTDs, you're going to reach out to your FTD team. If they're FortiGates, you're going to reach out to FortiGate. I have personally, most of my experiences doing this sort of thing is with FortiGates. And I will say, for all their other problems sometimes, FortiGate's AWS game is pretty impressive. They do this really cool thing where only the active firewall gets an elastic IP, right? So I put an elastic IP on my primary firewall, and then they have a little bit of automation that works that says if there's a failover event between my 2 firewalls, I'm going to disassociate that same elastic IP, and now I'm going to move it over here, right? And it does the same thing with the other IP addresses too. And so what happens is my elastic or my public IP floats back and forth between the two firewalls, depending on who's primary. And then the secondary doesn't really have an elastic IP at all. Or in FortiGate, they've also got this thing called the HA management interface. They both might get a public IP off of HA management to go out and register to the internet or download updates or something like that. But you wouldn't use it for uh, traffic for your clients or customers or anything like that. So it's a pretty slick thing. Other vendors have similar solutions. So the first thing you need to do is go work with your vendor to figure out how are they going to recommend you do that. What I didn't put in here is how do we connect to the rest of the network? It might be direct connect circuits. Again, that's similar to express routes. If you're an Azure person, we have at least 2 Azure people on the call. So you could do it that way. You could do it with VPNs. You could terminate your VPN directly to the TGW. The TGW does support IPsec VPNs. It has similar limitation of 1.25 gigabits per VPN tunnel. But your BGP is much more scalable. You can send it up to 1,000 routes. That's a lot better than the 100 routes. What if I'm working at a larger enterprise that wants to do multi-region for true DR, right? So I differentiate between HA and DR. To me, HA is I need resiliency between 2 devices. I have 2 routers so that if one router fails, the other router can take over. To me, that's HA or resiliency. DR to me is a much larger thing. How do I fail all my apps from here over to here, right? Whether it's a data center, whether it's a cloud, that's how I think of DR versus HA. So this might be something that you do for a DR setup. And maybe they say, I want one on the East Coast and I want one on the West Coast. And all you do really is you can spin up your 2 TGWs, you can spin up your VPCs, and we didn't go through it, but there is actually an ability to peer my transit gateways with one another so that region A can just forward its traffic over to region B, usually for like doing things like synchronizing your databases and stuff like that. And region B can forward its traffic over to region A. But what that means then is if region A, if the whole region goes down, or if I'm using direct connect circuits in both regions and the direct connect circuits go down or something like that, there's some catastrophic failure in region A, that means I could bring up all my apps over in region B. I might need to do some DNS magic, or maybe I'm using some automation to do the DNS magic for me because I'm going to be changing IP addresses, right? So this gets, I did one of these for an SAP install in AWS. It gets really complex really fast. But at the same time, it does work. It works pretty well. They've never declared a DR, but we did test DR multiple times and it worked just fine. So I have no doubt that they can declare a DR if they want to. Right? And final slide here, just some final wrap up tips and tricks. Remember, and again, everyone's going to get a copy of the slides that registered. Take advantage of that free tier if you're looking for learning some AWS. I believe there's a similar concept of free tier in Azure, and I know that there's a similar concept in GCP as well, right? You do want to be careful to understand what does free actually mean, what is free and what is not free, which is why I put the links in there. You may have noticed a common theme in networking. We quite frequently avoid using the default objects and instead create explicit objects that we want to use. We don't use the default VPC, we create our own VPC. We don't use the main routing table, we create our own routing tables. Don't use the default security group, we create our own security groups, right? Routing in AWS, it's a little more like a routing service. Can you imagine if Cisco sold you a router that had a maximum routing table size of 50 routes? No, you can't. Neither could I. So The TGW is a little bit better, but don't think of the TGW as anything like what you would get from like Cisco or any other routing vendor, to be honest. They are more like routing services than true routers. So there will be scalability limits and there will be a lack of features. So you need to be aware of those. You want to do those research items up front. Remember, we're going to treat each region we go into as its own new data center, right? And start there for your design principles, right? The last two are my opinion, but having been doing AWS for about the last 10 years, it's been my primary technology I've worked on is AWS. I will tell you that I think that cloud only works well when your teams work together. No silos in the cloud. There's no network team, there's no security team, there's no storage team, no compute team. You have your cloud team, and they need to involve network people, security people, storage people, compute people. This is not a technical problem. This can be a cultural problem, right? If your company is just used to working in silos, you need leadership to buy in, to break down the silos and get people working together. And there's a lot of, there's unlimited threads that you could read on whether cloud saves money, whether it costs more. Uh, the truth is going to lie in between those two endpoints and include those endpoints. I will tell you this, though. The only way you're ever going to, in my opinion, this is an opinion, the only way you're ever really going to save money in the cloud is if you take the time to actually refactor your applications to take advantage of cloud native capabilities. What I see, having done quite a few cloud projects, most people start with, let me just move what I have up into the cloud. They don't do any refactor, right? I think that's a responsible, good way to start. Your bill will go up, not down, most likely, right? But once you get things up there, and once your technical teams get more cloud savvy, then they start looking at, oh, you know what? We could refactor this. I don't need all these servers. Back when I was on-prem, I had VMs for everything. What could I do up there that maybe instead could be serverless architecture, whether that's like a Lambda or an API gateway or some other component or something like that. But then if I don't have servers, I'm not dealing with patching or anything else like that, right? So, but that refactoring your applications, it's a much bigger lift. So for the most part, you're not going to save the money until you take the time to refactor. What I have seen that has been most successful is people just need to start moving stuff into the cloud. And then once their team uh, accrues some expertise in cloud, or they hire the expertise, however they're going to go about it, then look at what does it take to refactor some of those applications and start with the easy stuff, not the hard stuff, right? Start with the easy stuff and then refactor it. And then you can see your bill come down by quite a lot, like up to 90, 95% sometimes, right? But you really have to refactor to take advantage of those cloud native capabilities. And that's all I have. Let me go ahead and stop sharing.
Need help? Call our cybersecurity team and book a consultation with us today.